Hey, welcome back, everybody. We're going to take a look at Activity 4.6, Design a Cam. All right, so here's basically the background with Activity 4.6, and that is previously with Activity 4.5, we went out and we looked at some very general use cams like the eccentric, the pear, the hexagon, and the snail cam. Those are very common shapes that you find within cams, but please know, depending on the application, is that sometimes that is going to require a specialized or a customized cam. And so that's what 4.6 is trying to tell us. That's what it's trying to show to us. In 4.6, we're going to see how to design a custom cam. Just please know that this is the process that you're going to use in order to create a custom cam. So PLTW has provided some information to us of the motion that they're trying to get out of the cam and how that has an impact on the follower rod in an assembly. But please know that you'll be following the same sort of process that you're about ready to see here in order to create a custom cam that you would like to help interpret the story or the motion that you're looking for at the top of of something like Automata. So with that being said, let's take a look. So when we take a look at 4.6, a couple things that they're going to be pulling out here is that they do give you a polar graph paper. It's a PDF download. So if we were to pick on that, this is the PDF that you're going to see. Yes, are there mistakes according to our math classes? Yes. 0 is showing straight up, and normally 0 is straight over to the right, at least in the CAD world. Please know you're going to need this, as students are going to be plotting points on the polar graph and then basically drawing lines to connect what the actual profile of this customized cam is going to look like. So please realize you do have to use that PDF. So just want you to be aware of where that is. Also, you're going to be seeing that there is a Design a Cam tutorial video. It's right here below procedures. So make sure you take a look at that. Some helpful things out there. In the first illustration we see, this is basically a vocabulary lesson of what you can expect in an assembly that we're going to be using for Automata. So take a look. We can see that we actually have this cam here. We have an axle that runs through the cam, and obviously these are going to be attached. At the end of the axle, we have our handle. Okay, and at the top of it, we do have our follower rod. Please note there is a guide in which the follower rod goes through. The bottom of that rod, we have some sort of a shoe, a plate, some sort of a boot that is going to allow us to have connection to the cam. And when this cam is being rotated, obviously the follower rod is going to be going up and down. So just as a small vocabulary lesson right there. Okay, so when we go down and we take a look, this is the motion graph that PLTW has provided on a custom cam. So if you take a look at the graph, we'll see in our y-axis over to the left, we're going to be seeing our distance in inches, and then across the bottom, we're going to be seeing the angle of the cam rotation in degrees. What they have gone out here and done is they have plotted points and connected those points, okay, to show us what the actual motion of and this is what I really wanted to reiterate. This is the top of the follower rod above the actual top of the box. So please keep that in mind. But here's what you have to know is in a 360-degree rotation, okay, of that cam, this is the motion that we're going to be seeing, okay, of that follower rod on top of the box. Okay, so that has been clarified. It says here in part 1, it says to assume that the minimum radial dimension of the cam is 1/2 inch. We want to replicate the motion graph, the position of the top of the follower above the box. So the first thing I'd like to point out is another little vocabulary lesson here about what is the minimal radial dimension of the cam. What does that actually mean? Something that is out there in the curriculum are these cam dimension drawings. And within each of these 4 cams, these are the typical, average general cams that are used throughout industry. You're going to see in these dimensions, okay, like for example in the pear cam, the distance, okay, from the axle, okay, to the very top. So what is going to be the maximum distance that this cam would be from the center, okay, is what we call the greatest radial dimension. Taking a look in this case, the very least that this cam would be, okay, away from that center point would be the least radial dimension, We take a look at the eccentric. This would be the greatest radial dimension from here to here, and then this would be the least radial dimension from there to there. Snail cam, this point to this point, and your greatest would be from here to here. With the regular hexagon, this would be the least radial dimension from here to here, and your greatest radial dimension would be from here to here. So just as a little vocab lesson on what that actually means, you just saw examples of it. Okay, so with that said, jumping back into the curriculum, let's see what we have to do here.